Hello and welcome back to this channel. Dear students, today's session is Jtag, that is Joint Test Action Group, and Boundary Scan. Let us first discuss the boundary scan. The basic concept is you have to test the circuit, or you have to test the internal logic of the circuit, as well as you have to test the connectivity between different components and so on, without making any physical contact. For this, the boundary scanning technique is used. In this method, all the flip-flops are modified into scan cells. This is a particular device which we are going to study in detail. So this every flip-flop is modified into the scan cell. You can operate it in the normal mode as well as in the scan mode. As the name indicates, in normal mode scanning is not performed, and in the scan mode a test pattern is applied and then the testing is performed. So once the test pattern is loaded, then initially you have to load the test pattern. Once it is loaded, the circuit switches from scan mode to the normal mode for one clock cycle. Then the test data is applied. This is the procedure. Then once the test data is applied, the circuit behaves like a shift register, because different scan cells are combined together as a chain, and it forms the chain like a shift register. So data is shifted from one point to the another point. You are supposed to apply the test data at the input, and at the output observations are made. So observe the output signal that is available at scan output pin. We are also going to discuss what are the different pins used in the circuit. So there are two types of scanning. First is full scan method. As the name indicates, the entire circuit is fully scanned. So we can easily say this is most reliable method, because everything will be scanned, everything will be tested. But it is the time consuming method. So this is the full scan method, which gives a good controllability as well as good observability. Next is the partial scan. As the name indicates, only a sub portion, subset, or only the critical part of the circuit on the PCB is tested. This is the partial scan method. Now let us discuss in detail about the boundary scan technique. Next, an important part is boundary scan method. From the exam point of view, you may expect the question like this: explain the boundary scanning technique and explain the function of every pin used in this method. So I have drawn the generalized block diagram. We'll discuss each and every part of this diagram. The major blocks are BSR, that is boundary scan register. This is the scan input. We have to apply the data. Data will be shifted serially in the serial form, and after scanning, the data is taken out from this. This is the scan output. This is input pin. This is the output pin. Then certain tri-state pins are also shown, as well as there are certain bidirectional pins which makes the movement of data in both the directions. This is the internal logic circuit, and we want to test this particular circuit. So what is the boundary scan method? Actually, this is widely used DFT standardized method as a part of Jtag. Jtag is Joint Test Action Group. Now, in case of normal circuits, the circuit is complicated. It contains millions of transistors. So in that case, it is very much difficult to physically access the particular point and then test the output at that point. So this method avoids physical access to that particular point, and it gives us effective solution, effective method to provide the testing of internal logic as well as testing of different connections and so on. So I have written some important points. So it is used for test interconnections. The interconnections is the connection made between different components, or you can well check whether any particular track on the PCB is broken or disconnected and so on. So it tests the interconnections. Then it is also applicable to test the internal logic of the particular device. I mean internal logic of the particular IC. Then input output pins can be well tested without any physical access. This is the major important point. What I said, in case of normal method, it is required to have a physical access for the testing purpose, but without physical access, we can test the circuit. important part in this case is boundary scan cell. Actually, this BSR, boundary scan register, contains a chain, a group of boundary scan cells. So this boundary scan cell is connected to input and output pins as well as at the different places in the circuit which you want to test. So it captures the data from each pin as well as it produces the data to the pin. When it is used at the input side, this boundary scan cell captures, accepts the data from the input pin, and after scanning, this produces the data to the output pin. So it produces data to the output pin. It creates the shift register chain. That means chain of shift register is created by using this boundary scan cell. So data is continuously shifted in and out by making use of this boundary scan cell. So group of such boundary scan cell forms one BSR, that is boundary scan register. Then another important concept related to this is test access port, that is TAP. Actually, it is the standard interface. If you want to allow certain external test equipments, then this interface is used. So it is the standard interface to allow external test equipments to control the boundary scan. Then different pins. This is important part. It's very simple as such. So four major pins are there. One is TDI, that is test data input. So it is input for the data. This pin accepts the data which is to be applied to the circuit for the testing purpose. Then TDO, test data output. From this pin, the data is taken out. Then TMS. There are different modes like normal mode, test mode, bypass mode. So this mode is controlled by making use of this pin, that is TMS, test mode select pin. Then TRST, that is test reset condition. It resets the condition or it clears the scanning. Then BSR, boundary scan register. As I mentioned, at different places in the diagram, I have shown BSR. So boundary scan cells are connected in series shift register. SR stands for shift register. So boundary scan cells are connected in a serial fashion in the form of serial shift register chain. It is called BSR. So as I said earlier, BSR is connection or collection of different boundary cells which are connected as a chain in the shift register, like a shift register. So the data is shifted serially to test the circuit conditions. Then one important block is there, that is instruction register. This block is not shown in this diagram. This instruction register allows external test equipments to control the different operations. So different modes can be controlled, like normal mode, test mode, and bypass mode. The basic advantage or basic working of this boundary scan method is it is applicable for interconnect testing. As I said, you can check the connection between the two components, or you can check whether the particular track on the PCB is disconnected or so on. So this provides interconnect testing. Next, internal logic testing. You can using this boundary scan method, you can check the internal logic functioning of that particular IC or of that particular device. Then in system programming, the different components, even the components, I mean CPLD, FPGAs are connected or soldered on the PCB. You can perform the programming or you can configure these devices. Then the function testing. The entire functionality of the device to total circuit can be tested at a stretch using this boundary scanning technique. Next part is the joint test action group architecture. So we'll discuss the Jtag architecture. This gives the simplified block diagram of the Jtag architecture. This block represents internal logic. Then these small square boxes, which I have shown four square boxes at RHS as well as at LHS. So each square box, each small square box represents boundary scan cell. We already discussed the function of this boundary scan cell. We also discussed that the number of boundary scan cells are joined and a chain like a shift register is formed, which represents or which creates the boundary scan register BSR. Then these four pins are the physical pins which are connected to these four boundary scan cells, as well as at this side again these four are the physical pins which are connected to these boundary scan cells, and all the boundary scan cells are connected one after the other. Then TDI is test data input pin. From this end we have to apply the test data to the circuit to check the circuit, to test the circuit. Here we are using one demux, that is demultiplexer. One output of demultiplexer is applied to this boundary scan cell, and then this signal goes on shifting one after other. This output is also given to the instruction register and data register. Then important block is tap control. We will discuss it in detail. At the output side we are using mux, that is multiplexer. Output of multiplexer is available or given to TDO pin. This is the test data output pin. The remaining two pins, TCK represents test clock signal pin, TMS represents the test mode select pin. Now I have written few important points related to this. As I said, tap controller is the major block. As the name indicates, it is responsible for controlling the entire testing operation. So it generates clock signal and control signals to control the operation of this boundary scanning. Then IR, that is instruction register. As the name indicates, the different instructions which are required to perform a particular operation should be given. So that is the function of instruction register. So instruction register is like SR, that is like a shift register, and it is loaded serially with the different instructions. Then according to that instruction, a particular operation is performed. Then DR, that is the data register. Actually DR contains number of registers, so you can say data register has bank of registers. The external stimuli, that means external stimulus signal. So external stimuli used to perform different operations are loaded in the data register. Then the output of this data register is given to the mux, and then it is available at the TDO pin. So this is about the Jtag architecture. So dear students, that's it for today's session. So thank you. Thanks a lot for watching this video.